About some exponential growth applications. Woo! Before we do, here's a would you rather question. These are my favorite. I'm really good at making these up too. Except I didn't make this one up. Alright, would you rather have the ability to fly or have the ability to turn invisible? Think about it. I see pros and cons to each. Would you rather? I think I'd rather have the ability to turn invisible because then you could go steal things like people's food at the lunch table, you know. And it just reminds me of Harry Potter. Anyway, why am I asking this? Well, this relates to a scenario that you have probably heard before, and if you haven't, then be prepared to be blown away. Would you rather get $100 per day or have 1 cent doubled in value every day? So let's think about this would you rather. So on the first day, that's a prettier color. On the first day, in this scenario, you'd have $100. In this one, you'd have 1 cent. So clearly this one. Okay. Second day, okay, now I have a total of $200, and now I have a total of 3 cents. So still this one's looking clearly better. So let's let some time pass. Let's scroll down here. Let's get to our, let's get to the 10th day. So after 10 days, if I'm looking here, okay, well now I have a lot of money here, and over here, if I added up this whole column, well, this is probably around like about $9-ish. You know, clearly this scenario looks the best. So let's keep letting some time pass. Okay, on the 11th day, I totaled this up. You have $20.47 in this case. Okay. 13th day, now I'd have a total of $81.91. So still, this column after 13 days, this $100 a day option sounds better. But let's start noticing what's going to happen here. And oh, Lordy. Okay. Okay, by day 17, okay, well my total in this column here, day 17, I have $1,700, right, in this option. But in this option, I have about $1,300, which, yes, the $100 a day still gets me more money, but let's continue to see what happens as time goes on. Whoa, 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 whoa. Okay, well now, here, remember I just went up a cent in whatever my total was. So now, my total is about $2,600, whereas this $100 a day is still $1,800. And you guys can see the difference here, right? I'm still only increasing by $100 a day. Here, I'm adding a cent to my previous total, right? That's pretty crazy. So what would you rather do? You should ask your friends this and see what they say. Clearly option B. Money, money, money. Okay, so why are we talking about this? Compound interest, to be exact. Compound interest is really, really important, especially when you become an adult and have to make big decisions, like I have to make sometimes. So compound interest, we do have this formula for it to find our ending amount depending on how much interest is being compounded. We also have a formula for continuous compound interest. And notice here's our buddy E again, which is a number, not a variable. What do all these things mean? P is our principal value. Another word for principal value is initial value, just what we started with. R is our interest rate, and just make sure, a lot of times interest rates are given to us in terms of percentages. We always write them as decimals when we're using this formula. N is the number of times compounded per year. So for example, if it's compounded monthly, that would be N equals 12 times, right? Okay, if it was compounded daily, that would be 365 and so on. That's how many times in a year. T is for time, A is for our ending amount. So, you know, what do I end up with? In terms of continuous compounding, these variables A, P, R, and T stand for the same thing. So let's practice. We are given $10,000. No, we're not given that. We're just given that information. Given $10,000 is invested at an interest rate of 3.2%. Find the balance of an account after 10 years if it is compounded quarterly, and also if it's compounded continuously. So let's have you guys go ahead using our brand new formulas, and let's see what you guys come up with. Go ahead, put me on pause. Scenarios here. This one is for being compounded quarterly, which I need to use my compound interest formula. My principal value was $10,000. My interest rate is 0.032. That's key. Time, 10 years. It said compounded quarterly, so that's going to be 4 times in a year. And then last but not least, we are solving for A, the ending amount, right? Find the balance, so ending amount. In that scenario, we get $13,753.76. In the continuous compound interest, we get $13,771.28. Obviously, these are pretty close. I think you would notice as time progresses that these would become more different, but, I mean, in this scenario, they're pretty similar. Okay, great job.